Today's lesson is going to be on fractions. A fraction describes a relationship between a part and a whole. We can have fractions of a set, which is part of a group or a collection of things, and we can have fractions of an area, which is part of a continuous area or a particular shape. Here are some pictures of things that would be fractions of a set. We see a collection of hats, some balls, and some marbles. Notice that the parts in the set don't have to be identical. They don't have to be the same size, they don't have to be the same color or shape. They just have to be a collection of something. Here are some pictures of fractions of a whole. You notice we have a pizza, a pan of brownies, and a pie. When we're talking about fractions of a whole, they can be any shape and there can be any number of parts, but the one difference is from fractions of a set is that when we're dealing with fractions of a whole, all of the parts must be equal in size. First, let's take a look at this fraction of a set. We see that we have 5 hats, we have 4 black ones, and we have one that is a yellow color. So how would we solve this as a fraction? Well, first of all, we have to determine how many things are in our set altogether. If I count up the hats, I have 5 hats altogether. And when we look at the number 5, that becomes something called the denominator. So I'm going to put right beside the word denominator, all. So that means all of the things all together, how many we have. And when we look at the numerator, that is whatever the problem is asking for. So if I said, what fraction of the hats is black, the numerator would be the part, or the part that I'm asking about. So let's write that as a fraction. If I said, what fraction of the hats is black, you would tell me that 4 of the hats are black. That would be our numerator. Then we put a little line like this. And the bottom number, which is called our denominator, would be how many hats we have altogether, which we already counted at the beginning was 5. Now, instead of me asking you what fraction of the hats is black, what if I were to ask, what fraction of the hats is yellow? In this case, you would count that there is only 1 hat that is yellow. Again, that is our part, so that is our top number or our numerator. And then we know our total number of hats altogether is 5, so the denominator stays the same as 5. I would read this as 4/5 of the hats are black and 1/5 of the hats is yellow. Let's do another example. As you remember, the denominator or the bottom number represents all of the things in our set. The numerator is going to represent just part of the set that I'm asking about. So look at the picture of the different balls. If I asked what fraction of the balls are basketballs, you would count and say, well, I only see 1 basketball. That is the part I'm asking about. That's your top number or your numerator. And how many balls are all together in the set? We have 4 altogether, so that's my denominator. Now, if I turned around and said, what fraction of this set is soccer balls? Then we would count the soccer balls. We see we have 3 soccer balls. That would be our top number. And again, we have 4 all together in the set, so our denominator stays the same. I would read this as 1/4 for the basketballs and 3/4 of the soccer balls. Let's look at one last example which has a little more to it. So we can come up with quite a few fractions for this picture. So we have a set of marbles here, and remember our denominator is always how many we have all together. That would be our bottom number of our fraction. Our top number will be whatever part I'm asking you about or the fraction I'm asking you for. So if I count up all of these marbles, I see that I have 10 marbles. Therefore, I know my denominator is going to be 10 each time because that is the total number in the set. Now, if I asked you, what fraction of these marbles are red? You would count up the red marbles and you would see that there are 4. So 4/10 of these marbles are red. Now, what if I asked you how many of the marbles are blue? you would count up the blue marbles, and I would see that there are 3. Again, our denominator remains the same. There are still 10 marbles all together in the set. So 3/10 of these marbles are blue. We also see some marbles that have sort of like a stripy color. So I'm just going to use yellow for that. So if I count up how many marbles are striped, I would see again that there are 3 striped marbles. So out of 10 altogether, 3/10 of these marbles are striped. You can also ask questions like, what fraction of the marbles are not blue? So if I said, what fraction of the marbles are not blue, I would count any marble that isn't blue. And I would see that there are 7 marbles in the fractions that are not blue out of 10 marbles in total. So 7/10 of these marbles are not blue. Now let's take a look at fractions of an area. It's a little bit of difference from fractions of a set. One difference is we don't actually have a collection of things anymore. We have one shape, and that shape is cut into parts. And the difference between fractions of a set and fractions of an area is with fractions of an area, the parts need to be equal size. So if you look at our first picture in our brownie pan, you can see that it is cut into 6 pieces. But if I look at these pieces right here, they're a lot bigger than the other 2 sections. So therefore, they're not equal pieces. Over on this picture, all of my pieces are equal. So I could make fractions with that brownie pan. I couldn't make fractions with the first one because they are not equal parts. So let's do an example. As you recall from when we did fractions of a set, when we talk about the denominator, that means all of the parts all together. And when we talk about the numerator, that is just the part that I'm going to ask about. So when I look at the area of this shape, if I count up all the pieces, I have 1, 2, 3, 4, 5, 6 pieces all together. So that's going to be my denominator or my bottom number. Now if I asked you how many of the brownies have been eaten, you would count up the empty spots. So there are 2. So you could say 2/6 of the brownies have been eaten. If I say to you, how many of the brownies are left, then you would count up the brownies still left in the pan. We can see there are 4 brownies still left out of the 6 that there were altogether. So I would say 4/6 of the brownies is still here. Let's do another example with a pie. Again, my denominator is all of the parts that would be there all together, and the numerator is the part that I'm asking about, or the fraction. So when I look at this pie, if I were to count up all of the pieces that should be there, we would count 1, 2, 3, 4, 5, because technically there would be a piece there if it was filled in. So therefore our denominator or our bottom number is 5. There are 5 parts all together in the pie. If I asked you how many pieces have been eaten, you would count 1. There's 1 piece missing, so 1 piece of the pie has been eaten, or 1/5 of the pie. If I asked you how many slices are still left, you would count the rest of the pie that is still there, and you can see that there are 4 pieces that have not been eaten out of the 5 that were there to begin with. So 4/5 of the pie has not been eaten. Now keep in mind, remember our denominator is our bottom number and our numerator is our top number. We're going to do a little more of a complicated one with more fractions now for this last example. So first of all, take a look at the whole pizza over here. How many slices can you see in that entire pizza? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that our denominator is going to be 10. That is our bottom number. That is how many pieces there are all together. Now, if I asked you what fraction of the pizza is pepperoni, you would count the pepperoni slices and you would see that there are 3. So 3/10 of this pizza is pepperoni. What if I asked you how many pieces of the pizza are green pepper? You would count the ones with the green pepper and you would see that there are 5. So you would say 5/10 of this pizza has green pepper on it. And then if I said, what about the mushrooms? How many pieces of pizza have mushrooms on them? You could say to me, 2/10 of the pizza has mushrooms, 2 out of the 10 slices. Let's look at this picture over here for a second. What if I said to you, how many slices of the pizza are remaining? Meaning how many are still left after everything else has been eaten? So again, you would count how many pieces are still left there, and you would see that there are 7 slices still left out of the 10 that would have been there originally, or 7/10 of the pizza is still left. Hopefully this video has helped you understand the difference between fractions of a set, fractions of an area, and how to show fractions using a numerator and a denominator.